Hello everyone, we have a question from physical chemistry, and this question is good for revision. And let me just get started. So there's this reaction going on, and we've been asked what would be the volume of CO2 gas at NTP, basically moles times 22.4, right? Okay, so let me just start by balancing this equation, and I would just ignore the H plus and H2O so that I can. Okay, so our balanced equation would be the following. Okay, I think that's fine. Okay, so now that we've done the balancing, I would come back to the question. And okay, so this question says that I took um, yeah 200 ml 0.5 normal of this solution, and I mixed it with this 300 ml 0.6 normal. Okay, so for MnO4 minus to go to Mn2 plus, where I have only one molecule of Mn, and the change is 5, so my n factor would be 5 in this case. So if I want to calculate the molarity, I would just divide by the n factor, and I would be left with the molarity, which is solution. And same. Okay, so for this n factor, you will have to do a little bit of hard work because you have plus 3 here and plus 4 here, but the net change would be 1 times 2 because you have to multiply by the reactant number of atoms in the reactant. So this would be 2, and here you would have 1. So the net n factor for the oxidation part of the reaction would be 3. Okay, and here you had n is equal to in this case you had n is equal to 5. Okay, so since you've got the both in factors, I can find the molarity, which would be 0.2 molar. Now the question is simple. You just have to find the moles of this. Moles is 0.3 times 0.2, which would be 0.06, and here you have moles 0.5, sorry, 0.2 times 0.1, 0.02 moles, right? Now you had in the initial reaction you needed 5 FeC2O4 and 3 MnO4 minus. Now you have 0.02 for this and 0.06 for this. So comparing both of them, I find that 0.18 and 0.1, this is in excess. So this thing is in excess. So if I want to find the amount of CO2, I would take this. So this would react with the number of equivalents of this, and the excess would be some FeC2O4 left, and this would actually determine the amount of CO2 formed, right? So 0.02 divided by 3 times. So I divided by 3, and now I have to multiply by the coefficient of CO2. So this is the amount of moles of CO2. Okay, so I would just directly multiply by 22.4, and um, doing the calculation would have 0.2 times 22.4 by 3. This is 7.4, yeah, 7.466, and 7.466 divided by 5 would be 1.493, 1.493. So the B option is correct. And the n factor, the main thing in this question was to find the n factor of the oxidizing part, which can be found this way. You have to first take you have plus 3 plus 4. You know the n factor would be 2 times the change in the oxidation number, and here you have plus 2 to plus 3, n is equal to 1, so the total is 2 plus 1, which is 3. Thank you. This would be the answer. Thank you for watching.